Hi, I'm Gary Ralph, and this is what I think might be the last of the series of lectures um, on European history, Europe and the World, Part 1, History 101 for the University of Delaware. And the last subject and a half maybe, that I'm going to be talking about is the scientific method and little postscript about the 30 Years' War, which I'm not going to talk a lot about. Scientific method, at the end of the last video, I started talking a little bit about what the scientific method amounts to. It is basically picking up again on the idea that when we observe nature, when we observe the things that are happening in the physical world, we shouldn't just say, oh, well, that's the way it is, don't ask questions. You can ask questions and you might be able to find something out about it. Now, in terms of the Renaissance and in terms of the beginning of the kind of revival of this idea, the person that usually is the start person is a Polish man named Mikołaj Kopernik. Most Europeans who had trouble with the Polish language referred to him as Nicholas Copernicus, and he lived 1473 to 1543. When I lived in Poland, which I did for a while, I was lucky enough to attend the Jagiellonian University where Copernic did his research. And in fact, there's a room there which was his astronomical observatory. They used to have his actual observing instruments, but those were stolen by the Nazis during World War II, and we don't know where they are now. So they have some reproductions of them. Copernicus was an astronomer as opposed to an astrologer. An astronomer is somebody who studies the motions of the planets in the solar system. An astrologer is somebody who thinks you can predict the future from doing that. And they were both in demand. Actually, astrologers were probably making a better living than astronomers because wealthy kings and people like that were always interested in finding out what the future would be like. Were they going to win the upcoming battle and things like this? And so they would hire scientists to examine the stars and try to figure out what the future was going to be. And a lot of them were saying, personally, I don't think you can do that, but if you're going to pay me money to study the stars, I'll study the stars. Copernic was interested in the movement of the planets. And for a lot of people, this was already a settled issue, because back in the Hellenistic times, there was a scientist named Ptolemy, not to be confused with the many pharaohs of Egypt who were named Ptolemy in the Hellenistic period. Ptolemy had written a book called the Almagest. Actually, that is not the original name, but it is one of those books that have been translated from Greek to Arabic to Latin. And during its Arabic period, it picked up the name Almagest, so it's actually an Arabic name. The Almagest was a kind of record or description of the movements of the planets. And Ptolemy had come up with this very complicated way of explaining why, rather rationalizing the movements of the planets. He couldn't really explain why they moved the way they did. He was just describing the way they did. And he was using as the assumption the idea that the Earth was the center and that all of the observations should be made in relationship to the Earth. If you do this, you end up with some very peculiar anomalies, because for one thing, if you're observing, for instance, the movement of the planet Venus as it goes through the sky from the point of view of the Earth, it seems as if the planet Venus is moving in one direction, and then at one point it kind of stops and moves in the other direction, and then it switches again and starts moving in the same direction again. This is called the transit of Venus. Obviously, today we know that this is an illusion. The planet does not stop and go in another direction. It has to do with the way we are observing it from Earth, which is also moving. But at the time, it was sort of like, oh, that's what the planet Venus does. I don't make up the rules. So Ptolemy had created this system for describing the planets, which didn't make a whole lot of sense. Now, Copernicus's when you hear about Copernicus, you're usually, what they say is he's the person who discovered that the planets move around the sun instead of the Earth. But that's not really his important, you may be surprised to find out, it's not really his important discovery. Anything, I could say the Earth moves around me. I mean, I could twirl around in a circle and say it's the Earth that is moving around in relationship to me, and I would be perfectly correct in that assumption as long as I described it that way. It's whether or not the Earth moves around the sun or the sun moves around the Earth. What Copernicus was saying is if you take the sun as the fixed point from which the observations are being made instead of the Earth, then your observations start to make a lot more sense. Copernicus said that the planets moved in circles around the sun, which they really don't. They move in ellipses. That was something that a later astronomer, Tycho Brahe, figured out. But the intellectual leap that Copernicus made, which I think he is rightly honored for, was not so much that the Earth moved around the sun as that nature moves in rational ways, that there are laws of nature that always work, and that they are comprehensible to human reason. They can be expressed in mathematical formulas. They are not just, Ptolemy, for all of his scientific expertise, was basically just saying, this is the way the world works, and I'm going to try to describe it to you. But he came up with this very complicated explanation, which did match the movements of the planets, but it didn't make sense out of the universe. And Copernicus was trying to make sense out of the universe and say that the way the universe works is a way that the human mind can comprehend. This is basically just an assumption in a way, and there's nothing to prove that the universe works in a way that the human mind can comprehend. And, in the 20th century, we begin to come up with things like, Einstein's theory of relativity, which is not the easiest thing in the world for the human mind to comprehend. But the idea was that having made this assumption, it opened the door to a lot more scientific investigation. That's the word I want. Whereas, if you had been operating on Ptolemy's level, you would have just said, well, you just have to observe it and write it down. Can't make any sense out of it because it doesn't make any sense. So you begin to have this group of philosophers growing up in the Renaissance who are saying, you can look at the world and you can find the laws that govern nature, and they should be laws that you can find. There's no point in saying, we'll never be able to make sense out of this. You can make sense out of it because the world operates in a rational way, or in a way that is able to be understood by the rational mind. Now, I'm not going to talk about all the scientists in the Renaissance. There are too many. But I wanted to look at a few of them just to illustrate the different ways of thinking. One of the important scientists was René Descartes, a Frenchman who was primarily a mathematician. His famous statement that you've probably heard is, I think, therefore I am. Je pense, donc je suis. And the reason this is important is Descartes says, once you make that statement, once you say that you are accepting the fact of your own existence, you can use Cartesian logic, which is named after him, to determine everything else about the world. That it doesn't really have, Descartes says it doesn't really depend on your observation of the world. You can figure it all out from logic, which people today refer to as the deductive system of logic, deductive system of science. In contrast with, for instance, a man named Sir Francis Bacon, an Englishman, whose idea about science was that, you do come up with a theory about the way the world works, but then you conduct experiments and you test the theory. And if the experiments show that the theory is not right, you have to adjust the theory until you get a theory that actually always is predictive of what's going to happen. And then you know that it's a true theory. And this is called the inductive method, where you argue from the evidence of reality. Now, one of the greatest scientists of Um, the Renaissance was Galileo Galilei, who basically combined these two methods. Galileo, I don't know why everybody calls him his first name, was a wonderful investigator. He invented new kinds of telescopes and made better observations of the movements of the planets and things like that anybody had ever done before. But then he also came up with great mathematical theories to describe and, again, really in a way to explain what he had observed. He wasn't just saying, well, this is what I saw, take it or leave it. He says, this is what I saw, and the reason that it happens this way is that it always happens this way, and I can describe the way it happens in a mathematical formula. So, very briefly, that is the substance of, take a course on the history of science. It's all very fascinating. I wanted to touch on one more thing, though, which is, why does this course end in 1648? Well, it ends in 1648 because that's when the 30 Years' War ends. I mentioned the 30 Years' War earlier in my discussion of the Reformation. It was started as a war between Philip II of Spain, who was Catholic, and the people who were supposedly his subjects in the northern Netherlands, who were Protestant. So it started out as a religious war. And for the first part of the 30 Years' War, which is the last 30 years of the 80 Years' War, as I explained in the lecture on the Reformation, it was Catholics versus Protestants. It was a religious war. But as time goes on, it becomes less and less of that kind of thing. I've got a chart here that I copied from a book about the 30 Years' War. This, on the bottom, you've got a list of all the different nations that participated on one side or another in the 30 Years' War. And you can see it's just about every nation in Europe, which means that there's a lot of fighting going on. And also, from the point of view of military history, it's a very destructive war. I mentioned earlier in the 100 Years' War that was destructive because the governments didn't have control of the means of violence. In the 30 Years' War, you might say that the governments had not worked out problems of logistics. By the 30 Years' War, their soldiers were full-time soldiers, but they hadn't figured out ways of transporting the soldiers from one part of Europe to another, and they went all over Europe during the 30 Years' War, but also providing them with food and money. So what happens is that the soldiers march upon a harmless little inoffensive German village and take all their food. And then 3 weeks later, another army marching in the direction marches through the city, and whatever they've managed to scrape together in the intervening 3 weeks, that army takes all of that. There were some cities for whom that happened dozens of times during the 30 Years' War. And, there was starvation and horrible things. So at the end of the 30 Years' War, there is this it's a series of treaties that together are referred to as the Peace of Westphalia. And that happens in 1648. The reason that we use 1648 as the stopping point for Europe and the World Part 1 is partly because if you take a textbook of European history and you divide it right out of the middle, it usually divides it around the Peace of Westphalia. But a lot of historians believe that the Peace of Westphalia also represented a new Europe. It was the first time that practically all of the European countries had gotten together and said, we cannot have another war like this. We are all bankrupt. People are, there's corpses of people all over Europe lying in the street because they've starved to death. We cannot afford another war like this. So they basically, through this series of treaties, the European countries all get together and say, look, I'll mind my business if you'll mind yours. And if somebody else gets into your business, I pledge to prevent them from doing that. So it's, some scholars have connected this to the later development of things like the United Nations, where all of the nations are really working together. There's no nation anymore after the Peace of Westphalia who says, I can do whatever I want to and phooey on you. There's the sense that, you can't pick on other people because if you pick on other people, they'll pick on you, and you don't want that to happen. So it's in some ways the beginning of modern Europe. And of course, I've mentioned a lot of the other things that have mentioned that lead us gradually to modern Europe. But I think it's fair to say that from 1648, it's a different game. the Europeans are playing. But in any case, whether it's a different game or not, this is the end of Europe and the World Part 1. I've had a wonderful time recording these lectures. I hope you've had a wonderful time watching them. I love you all. I hope you love me. Have a wonderful life. Bye.